Section 7.4, Special Right Triangles. In this section, we're going to look at two kinds of special right triangles. The first is our isosceles special right triangle, which means it has angles 45 degrees, 45 degrees, and 90 degrees. The second is the right triangle that has angles of 30 degrees, 60 degrees, and 90 degrees. Well, let's look at the first one, our isosceles right triangle that has 45, 45, 90. Theorem 7.8, which is the 45, 45, 90 triangle theorem, tells us that in a 45, 45, 90 triangle, the ratio of the sides of the triangle is in a constant ratio of 1 to 1 to the square root of 2. Well, we already know that since it's isosceles, the two legs must be congruent, putting them in a 1 to 1 ratio. So whatever value BC is, CA is that same value. What we find out, though, is that the hypotenuse is then the length of the leg times the square root of 2. So right now, make sure that you have these values down in your notes, that for a 45, 45, 90 degree triangle, we're in a 1 to 1 to the square root of 2 ratio, meaning that a leg of value x means the other leg is also x, and the hypotenuse is x times the square root of 2. Let's look at a couple examples before I let you try one on your own. So if one of the legs was, let's say, actually we'll put it as the square root of 2. That means the other leg is also the square root of 2, and the hypotenuse is the square root of 2 times the square root of 2, meaning it's just 2. Alright, how about this? So we know to go from the leg to the hypotenuse, we need to multiply by the square root of 2. But what if I gave you the hypotenuse was 10 square root 2? Well, to go from the hypotenuse to the leg, you need to divide by the square root of 2. The leg is 10 root 2 over root 2, which is just 10. And we can look at one more. What if your leg was 3? The other leg would also be 3, and the hypotenuse would just be 3 square root 2. Okay, so take a moment, work through example 1 on your own. Given these triangles and given the lengths of the sides, fill in the missing side lengths. Pause the video if you need to, and then restart when you're ready to see the solution. Well, first of all, for both of these, this one, since our angles are 90 degrees and 45 degrees, the remaining angle must be 45 degrees. And in this right triangle, since it's an isosceles right triangle, we know the two base angles are congruent, meaning they must both be 45 degrees. Thus, we have our 45, 45, 90 triangles. In this first triangle over here, since the leg is 5, the other leg must be 5. The hypotenuse is 5 times the square root of 2. In the second right triangle, our hypotenuse is 12. To go from hypotenuse to leg, we want to divide by the square root of 2. So our leg is 12 over the square root of 2. However, we really don't like having square roots in our denominator. So what we want to do is multiply by square root of 2 over square root of 2. This is the same as multiplying by 1. We know anything times 1 is itself. What we get is 12 square root of 2 over, well, square root of 2 times square root of 2 is 2. Our 12 and 2 reduce, giving us 6 square root 2. So both of our legs are 6 square root 2. And that is the answers to the example. If you're comfortable with the 45, 45, 90 triangle, you're welcome to move on to the 30, 60, 90 triangle.